So today we are starting a very new series on system designs. And the very first problem which I would like to start with system design is design a URL shortener. Um, so I'll start from the very scratch about designing a URL shortener. So there are some important techniques which are very important before you present yourself for any system design interview question. So I highly recommend that whenever you are kind of, in sitting in front of an interviewer and you have been given a system design problem to solve, so there are very common, important tricks that you always should have in your mind. So I will kind of, note down those things here. So I'm using Miro board, and I'll write down all those things here, which are very important. So the very first thing which on a very high level is you have to talk about high level components. You have to talk about how those components communicate with each other. You have to talk about database design. You have to talk about API designs. You have to talk about functional requirement and non-functional requirement. Then at the end, you have to talk about technologies that you are going to use. So all these things are very important. So what are those important things? So the very first important thing is high level components. High level components, right? So let me increase the font. Yeah. So high level components. This is one. And then yeah. So this is one high level component. All right. So let me increase the font a little bit more here. So this is high level component. Second thing which I said are very important, which you have to discuss all about is how component communicate. Okay. So what are those components? On a very high level, those components are front end. Okay. This will be one component. Then your API gateway. This will be another component. And then your shortening service. All right. So before we just move here, I just want to put another box, which will be URL shortener. Okay. So this is my uh, system design problem, URL shortener. And these are the things which are very important. So high level component shortening service. And then we have database. So all these high level components, they are important. Okay. And then how components communicate, meaning how front end is communicating with API gateway, how shortening service is communicating to database and all those things, right? So those are the things which you will cover here in this piece, like how component communicate. Uh, so you talk in this particular portion how component communicate is like how user inputs a long URL into the front end, and then front end sends a request to the API gateway. All right. And then API gateway calls the shortening service, and then shortening service generates a unique ID, maps it to a long URL, and then stores it into the database, right? So these are the two things. And then number three is database design. So this database design on a very high level um, should talk about like all the important entities and tables which this system design problems is going to use. So for example, URL table is one of them. All right. So you have to talk about the table name. You have to talk about the columns in the table like primary keys, long URL, created at, timestamp, like all those things, right? And then we have to talk about API design. In API design, we are going to talk about like what URLs you're going to have. Like for example, post URL could be like shorten, and then get slash short URL could be your get, which will return the short URL for a long URL. Um, long URL for a short URL, and post will return the short URL for the long URL that you post. Then we have non-functional requirement. Then we have functional requirements. All right. So these are on a very high level. We should always keep in mind, and then TECHNO, technology used. So technology used in all those components and all those things, right? Which database you are using, which technology you are going to use, React, Angular for front end, what you are going to use for API gateway. Are you going to use some cloud service provider, shortening service, Node.js, Java, what backend you are going to plan for this database, if it is a MongoDB, MySQL, Redis, and all those things. Like, are you going to use some cache, Redis, and something like that? If yes, then we have to talk all about this. So this is on a very, very high level, right? Uh, I mean, every question should have these 7 important items to be discussed as part of every system design problem. All right. So now we will start with one of the very important component here, which is shortening service over here, which is the backend component. Why I do not want to focus on front end? Because front end is not the scope of this session, because front end is actually a plain single Node.js application. You can scale it, uh, deploy it to AWS. Let's say, for example, scale as you have your user load. Uh, and then API gateway, definitely this is also a very scalable component. You can use one of the AWS cloud services for API gateway. That is also very easy to scale. This can be written in React. This can be AWS or any other cloud provider you can use. Shortening service is the important component or service which we are going to talk about, right? So how this shortening service, we will talk more about this. Database is something that we can also talk about little bit, and then we will see how we are going to deal with this, right? So let me start with this shortening service. So I will copy this shortening service and move. Yeah. So here I copy this and paste it here. Hmm. And let's move me this to here. All right. So now I will start with this shortening service, right? Shortening service. Okay. So this is my shortening service. So what are the responsibilities of my shortening service? So shortening service has got following responsibilities, which are very, very important to understand. Um, so the responsibilities which my shortening service will have is: one, generate a unique short URL. Generate a unique short URL. Okay. And then store the URL mapping. This is also one of the responsibility. And then provide redirection. Okay. So these are 3 main important uh, core functionalities that our shortening service should have. So when I say generate a unique short URL, what does it mean? It simply means that the core function of the shortening service is to take a long URL, okay, and generate a short URL that redirects to a long URL. The short URL should ideally be unique and concise and easily reversible back to its original URL. Second, it stores the URL mapping. What does it mean? It simply means that the service stores the mapping of the short URL to the long URL in the database. And this is a simply key value pair, like short URL ID maps to long URL ID. Then point number 3 is provide redirection. What does it mean? When a user accesses a short URL, example, let's say HTTPS, then some URL and then slash ABC123, then the service looks up the short URL ID and then it redirects. It's fetching it from the database to the long URL and redirect the user to it. So these are the very high level core functionalities that we are expecting from the shortening service. Okay. So high level steps in the shortening process will be very simple. Okay. So let's say you have one input URL. Okay. So I'll simply quickly just design something here. So let's say you have here one input URL, which is um, input. Okay, let me increase the font. Okay, so let's say it is HTTPS. Okay, it's okay, HTTPS and then abc.com. Okay, so let's say this is one of the input long URL, and maybe I can just increase this. Okay, let's say this is one of the input long URL. This is long URL. So what should happen? This long URL, when it is coming from the front end, a request, then uh, generate short URL. So URL ID. So shortening service over here, this shortening service generate a unique identifier for the short URL. Okay, and this ID can be generated in different ways. So over here, generate unique ID for the short URL. Okay, and then when it generates a unique unique ID for this, then what it will do, it will then, next step is store mapping of long URL to short URL. Okay, so this mapping will be stored in the database, and then next step will be return short URL. All right, so this is on a very high level. This thing work like this, right? So if you see here, so these things, they will work like this. Like, you have from the front end, you have a long URL coming in, then this sorting service will perform these actions, generate unique ID first for the short URL with whatever input it got, and then store mapping in the database, and then it just generate return the short URL which is stored in the database for you. Okay, so this looks very simple and straightforward. But just imagine you got some input which is a long URL. There is a Java service sitting behind. It takes the input, it generates a unique ID, and then store that long URL and then the unique ID, which is a short URL, into the database, and then return the unique ID to the end user, like to the front and back. So it is very simple. But how and what will be the scenario when, let's say, you have million and billions of users accessing the same shortening service? So what will happen? Let's say you got one very big cluster, okay, where you have number of, uh, I would say, your servers running different services, different replica of this shortening services, because as I said, it's a very big user base, like more than 1 billion. Let's say there is a requirement. Okay, so this shortening service, every single replica of the service is actually generating some unique ID, and for generating a unique ID you can use, different libraries, but the chances of getting the unique ID is probably, you know uh, expected to be to have collision. Why? Because the very first question comes in, how you can generate a unique ID. right? So generating unique ID, there are different ways. You can use hashing. So for example, you use a hash function like MD5 or SHA-1 to generate a unique hash from a long URL. Okay, so you can have, I will just write on here, like one hashing. Okay, so it will have SHA-1 or let's say MD5. Then you can have your UUID, or you can have something like, yeah, so you can have auto, uh, like base 62 encoding, for example. This is also base 62 encoding. So there are different techniques which we can use to generate a unique ID, right? You got a long URL which is a key, and then with this long URL, like you can generate uh, unique key using hashing, using UUID, um, using base 62 encoding. So out of these techniques, which technique is the best, right? So for example, if you need your you have very simple basic application where there is no requirement of scalability, right? So any of those approaches would work. I mean, you can definitely start with basic UUID approach because you have one machine, one application, and probably only one company where you're using UUIDs. All right. But let's say if you want to use your application across many different countries, globally distributed, then you have to be very, very careful about collisions. You have to be very, very careful about that your service is generating unique IDs, right? There is no collision. So in that case, UUID approach is not going to work because let's say if you're using a library, that library, the probability of generating the duplicate unique IDs by different instances or different instances of the same service running across different cluster data centers is high. Collision frequency is high, right? Similarly, hashing is again going to give you more, uh, I mean, risk of having collision. So I will explain you um, all these approaches one by one. So this base 62 encoding, okay, this is one of the encoding which is the technique wherein we are kind of going to use 62 characters, like starting from A to small z, like all small letters A to Z, capital letters A to Z, and 0 to 9. So total 62 characters. And any single integer, if we are encoding it to base 62, all right, we are going to have a unique ID always. That is for sure. So, in simple, if let's say you are asked to generate a unique ID, um, and you are asked to generate unique IDs for, let's say, fixed number of users, so it's very easy to find out. Why? Because, uh, okay, let me talk about numbers. So when you say base 62, and let's say you want to generate 6-digit unique short code, 6-digit or 6-character long short URL using base 62. So in that case, base 62 says, here is base 62, all right? Base 62. So it takes total 62 characters, all right? And what does it mean? It simply means that 62 to the power 6 to power 6, which is nothing but around 56 billion unique short URL can be generated. All right. And if I just increase this number to 7, so for example, how many 7-character long short URLs can be generated? Then 62 to the power 7 will be equal to around, it's going to be a very big number. So it would be around 62 to the power 7 would be around 3.5 trillion, okay, short URLs. They are, we can generate those enormous capacity of short URLs. So now it again depends on choice of your system that you're designing. You think that you really need 3.5 trillion of short URLs in your application because of the user base. Choose your base 62 algorithm accordingly. So 6 is also fine. 56 billion is a big number. 7, it is giving you very enormous capacity, like very low collision risk for generating the uh, short URLs. Okay. So now coming to the part which is very important, like different approaches that we discussed. So the very first approach, let's say we talk about auto incrementing. Okay. So there is also one more approach which is called auto increment. Auto increment, increment ID with base 62. Okay. So this actually this is same. So I will instead remove this. Yeah, and replace this with this. Okay. So what does it mean? So every time when we have a long URL request to have a short URL from the backend, the shortening service which is sitting on the backend, it takes the long URL, okay, but it is not going to actually take the long URL for generating the key, okay, for generating the unique key. Instead, what it will do, so the no two users, okay, get the same sort URL when the using a URL shortening service. We need a strategy that guarantees uniqueness for every sort URL, right? So what we will do, so what will happen, so for example, let's say um, s- uh, the system starts with value, let's say 1, and then converts this integer into base 62 string, which consists of all those characters. So for example, 1 becomes base 62 equivalent A, 2 becomes base 62 equivalent B, integer 123 becomes base 62 equivalent character. So all this that you see um, will convert into base 62 equivalent. Now, the important part here to understand is, in this case, when you are auto incrementing ID, what is happening? The long URL comes in, this service automatically increment one of the counter which it maintains within the service. So what we can do, so for example, let's say we have a distributed, uh, I would say very highly scalable environment where we have different instances running for this particular service. So what we can do, let's say we can generate, we can give the responsibility that every single service will start with a counter, okay, and every time a request comes into that particular instance of that service, the counter will increment, and that counter is is used in our base 62 algorithm. So base 62, if you see here, base 62, this is our simple Java code. I mean, you can copy this and you can see this Java program. So what base 62? Base 62 need a value here, right? So it could be 1, 2, 3, whatever. So let's say it got 1. All right. So when you pass 1 here, and so this actually is giving you 1 as an input. Now, when you pass 2, 3, 4, 5, 6 a number like this, it is giving you again this encoded W7E, okay, 3 digit. So every time this value you can increment within the service, so that whenever somebody hit that particular service, they will always make sure that they are getting a unique short URL, okay, because if the ID is unique, it will go into this base 62 logic and it will generate you the unique short URL. It's very simple. All right. But let's say if you have given the same concept, meaning let's say you got 1000 replicas of the service. In every single service, let's say have some logic like having counter approach, which is starting from 1 and then let's say keep on incrementing. So you can easily guess that there is still a chances of collision. Yes, because what is happening? So let's say you have over here, okay, so let's say I have so many services, okay. So these are so many services which are running. So there are many services replicas are running, and every single service which is a shortening service is doing the same thing, like maintaining a counter, incrementing it for every request, and generating a short URL using this base 62 algorithm, isn't it? But if they are having their own replica set, then a user who is logged in into this instance, let's say the getting probability of having one short URL having the collision, meaning the short URL returned to this particular user who logged into this service, um, is same then with the probability of user getting the same short URL from this particular service, because they are using the same approach. So instead of having, what we can do, we can still have this counter approach, but let's say what we can do, we can again make, let's say, another service. The responsibility of that service is to create a set of counts. So for example, let's say I know we have 1000 instances, right, running for my services. So what I would say, instance 1 will have limit set from 1 to 1 million, all right? And then instance 2 will have 1 million, 1 to 2 million. Instance 3 have 2 million, 1 to 3 million. And like this, we can have till 1000 instances. Now, of course, we are all these service when they start up during the warm up time, what they can request their respective uh, count set 1 to 1 million from this particular service, all right, and then give it to each respective service. Now that particular problem where there was a collision, there was a risk of collision happening returning the same URL now among these services is completely reduced. Now all these services, they are kind of dependent on one this single uh, point of failure, which is returning all these services the count. So what we can do here so that this single point of failure can be fixed. So over here, we know that uh, we have created one single instance, uh, which is maintaining having all the information about all the instances running across all the clusters and maintaining the counter for all those. And those counters are used only within the services to generate the short URL. But what if this fails? So we have to have this service highly available and having its replicas set in such a manner so that even if it crashes, there is always uh, someone else to take the responsibility of um, having this, s- uh, returning this to all these independent services. Like, because every service they cannot run unless this service is up. All right. So let's say this service start, got its count, and this is instance 1, got its count 1 to 1 million. So every time any request coming into this service from shortening service from UI, so it will always generate and take that unique ID from 1 to 1 million only. When it is done, then it can call again the this instance to give the new set of count. Okay. So similarly, all these services, they can talk to this service to give, and the responsibility of this service is not to maintain the counts, but also to check that if the count is exhausted or not. So for example, when every service is almost done with the count, then it can send a message to this service that, hey, I'm done with my count, then I need a new count set, right? And this service will return the new count set. And we can make this data persistent somewhere, because this is not very high um, size, like this is very small size data. You're just maintaining a counter and storing somewhere, that's it, right? So having the replicas of this service is fairly very easy, and the load on this service is also not very high. So the risk of getting completely fail, or let's say fault tolerant of this particular service is rarely very, very low. Because as I said, you just imagine that we are storing key would be the name of the instance, and value would be the the range that that particular instance will use for generating the unique ID. And it's a very small data set, right? And we can create replicas for this. So for example, let's say if some service is trying to reach this, not able to reach one instance, it can talk to other instance, whichever is available. And all these instances, they among themselves replicating the data, meaning or synchronizing the data, the correct word, not replicating, because they should be in synchronized. So I will say we will also scale this service. I'll copy this. So we will also scale this service like this, so that they all are synchronizing with each other, right? In real time. So s- every time, anytime when we are these shortening services, they are trying to reach, if they are trying to reach here, yeah. So all these shortening services, if they are trying to reach one of the instance of this service, so it is very, very low chance to have a complete failover. So with this strategy, our system is really, really very good. It's able to generate millions and trillions of um, short URL for any request coming in. All right. So I think this is very easy. Now you got to know what approach I'm using. Uh, Hashing and UUID, these approaches can be used, but they are not made for very highly scalable, highly distributed application environment, right? So they always going to work when your environment is not very like low, small uh, environment where you do not need to scale a lot. All right. So coming to the part where we are going to again discuss one of the important thing, which is, okay, let me take this up again. Okay. So now, as I promised, we will discuss some of the important thing. But before we go into this important thing, I would like to explain you what this logic base 62 do. Okay. So over here, you see here base 62, I considered all the characters, capital letter A alphabets 0 to 9, small letters. So this is 62 characters. And this is the encoding logic, which is very simple. You are generating a string, okay, from string builder. And what you are doing, every time you are trying to find out the remainder, and whatever remainder it comes, that remainder will map the equivalent value from the this array, and then we decrement. So for example, let's say 1 2 3 4 5 6 was my initial number, so we get the remainder, which will be 14, and then 14 equivalent will be 0 1 2 3 9. Okay, and so it will be 10 actually, instead of, because if you talk about indexes, so 9 will be 10, 11, 12, 13, 14, 15. So this is E. All right. So that is why you see E here. And then next time when it comes, it will be 1, 2, 3, 4, 5, because you are doing this. Sorry. So yeah. So next time 1, 2, 3, 4, 5, 6 will actually take this 14, because when you divide value by base, so it will not give you the remainder, it will give you the quotient. Okay. So this is remainder, and the quotient will be somewhere 1992. So I'll also print the quotient so that it's very easy for you to understand what exactly that question means. All right. So this is value. Okay. I run it again. Uh, okay. Here, here we go. So you see here 14, and the quotient is 1991. Now 1991 again gave us some remainder. So this time remainder is 7. So over here 7 index will be this. Okay. This 7. So that is why this 7 is printed here. And then when you have 7, and then you have to do again, uh, do it like this. So you have your 62, but the quotient would be 32, right? So that's why we have 32 here. So when you just do 32 and then divide 32 by 62 again the remainder will be, I mean, because the quotient will be 0 and the remainder will be 32, because 32 minus 0 will be 32. So this time the remainder is 0. So when you have, so when it is 32, so 32 will come here. Okay. So W will be 32. So this is W. So W7E will be my encoded character. And this is very simple algorithm. So whichever way you have your input string created, your algorithm will work that way and generate your unique encoded characters. So most of the time I know that people, or interviewer, they ask us like, hey, you need to generate short URL 6 letter long, right? So let's say if the length of this encoded string is less, let's say over here it is 3. So what you can do, you can pad some characters in the front, okay, or so that the total length of this character is 7 or 6 or whatever you want. So that way you can maintain it. All right. So lot of talk on the shortening service. So I think you all got this shortening service in a better way. What we have to do. Now we will talk about more a little bit about like those components which I told you in the very beginning. Is that API call and those things, right? So all right. So when it comes to API, uh, there are two important API designs.